Swayam Prabha. Digital India. Educated India.
So, in my previous lecture, I have discussed about the pseudodynamic method to determine the active earth pressure or force on a retaining wall, and then I started one example problem to show that what are the forces we will consider to design a water font retaining structure, and how we will determine those forces. So I have given those parameters. So, I will start from that part itself. So, these are the parameters. So, we have the base soil parameters are given, then the backfill soil parameters are given, then the dimension of the wall is given, and then what are the seismic acceleration coefficient Kh, Kv, those values are also given. So, first I have to check whether the Kh that 0.1 that we can apply or not. So, to do that, first we have to check the, say, this is a partially saturated case. We will calculate the average unit weight gamma bar, and that that is equal to lambda square into gamma sat plus 1 minus lambda square into gamma dry or bulk. So, here lambda is how much? Lambda is 0.833. So, 0.833 whole square gamma sat is 20 plus 1 minus 0.833 square gamma dry is given 18. Okay. So, the average unit weight is coming out to be 19.4 kilonewton per meter square. Okay. So, 19 kilonewton per meter square is the average unit weight. Okay. So, now I will check whether that K critical value which is within the given value or not, whether there is a solution is possible or not. So, this is a partially saturated case. Okay. So, that the K critical expression is gamma bar minus gamma W into 1 minus Ru into 1 minus Kv divided by gamma bar into tan phi f. Okay. So, I can calculate that my gamma bar that is equal to 19.4 minus unit weight is 10 of water, 1 minus Ru is 0.5, 1 minus 0 because Kv value is 0 divided by 19.4 into tan 5 backfill is 35 degree. Backfill is 35 degree. So, it is coming out to be 0.17. So, which is greater than 0.1. So, that we have taken, so it is okay. So, that means we can apply 0.1 Kh value because our critical Kh is 0.17. We cannot provide the Kh more than 0.17, but it is less than that. So, it is okay. So, now if it is okay, then what is the value of theta? Theta will be tan inverse gamma bar into Kh divided by gamma bar minus gamma W, 1 minus Ru, 1 minus Kv. Okay. So, if I put those values, then it will be tan inverse gamma bar is 19.4, Kh is 0.1 divided by 19.4 minus 10 into 0.5 into 1 because Kv is equal to 0. So theta will come 22.4 degree. So theta will come 22.4 degree. Now here in the K, now I have to calculate KAE. Now in KAE, all the values are now known. So you need the phi value is known, beta value is known, your beta is 9.6 degree, phi is known, delta field that is known. So your theta is now known. So I is equal to 0, it is given. So you put all the value in the KAE expression, you will get the KAE, that is 0.84. I am not showing that calculation because I have already shown similar calculation in my previous problem when I solved that pseudostatic analysis to determine the seismic force on a retaining wall. So there I have shown how to calculate KE. So because you have that expression, I have already given you the expression. You put this value, you will get KE. With all the values are now known. Okay. Similarly, KA also I will get by putting those value in the equation, and that is they will give you 3. That will give you 324. So KAE is 0.84 and KA is 0.324. Okay. So now I will calculate the PAE value. So now this is for PAE, partially saturated condition. This will be half gamma bar minus gamma W into 1 minus RU 1 minus KV into KAE into H square. So this PAE will be half. This is 19.4 minus 10, 1 minus 0.5, KV is equal to 1, KAE is 0.84, H is 6 square. So this value is 71.1 kilonewton per meter. So let me again draw all the forces, because here we are assuming it is a free water, pore water condition. It is a free pore water condition. We are assuming it is a free pore water condition. So that's why we will consider the PDW in the both the side. Assuming the free pore water condition. Then what are the forces? Other forces. So this is my 90 degree. So this is PAE. Okay. And then PSW. Then this side PS dash W. And here the weight will act. Then this is KHW. Similarly, I can put KVW also, but here KV is equal to 0. So these are the forces, and point of applications are also been given. And one more thing, there this is I am considering this is a foundation soil, but the water table height I will consider, the water height I will consider as it is 5 meter from the base. I will consider the hole as the seaward side water height. Clear? I will consider the hole to be in the safe side. So now this is the 71.7, and now your, okay, so this height also I can write here. So let me write those heights. Okay, what about this? This is h by 3 from here. H by 3 will be 1.7 meter. So this one is 1.7 meter. This one is also 1.7 meter. Then this is this water dynamic water pressure. This is from the base, it is 0.4 H. H means 5 meter, 0.4 into 5, it is 2 meter. Okay. And the H bar I will calculate, so that I will show you how I will calculate the H bar. Okay. And then this W position, centroid position also I have to calculate. Centroid position I have to calculate. That I will also show. So now let me calculate the other forces. This is PAE. Okay. So PAE is 7.1. Now to calculate the H bar, I need PA. So in case of PA, what I did, I also use the same recommendation that is been given for PAE. Because here also in the PAE expression, I have given the same recommendation, replaced by gamma bar, gamma W 1 minus RU. That is the recommendation for KE, because PAE actually in the dry condition, PAE is what? Gamma into half into gamma into 1 minus KV into KAE into H square. So that this gamma is being replaced by gamma bar, gamma W into 1 minus RU. This gamma is been replaced. If it is partially saturated, fully saturated, then it will be gamma sat into 1 minus, gamma sub. This will be gamma sub. This will be gamma sub into 1 minus RU. That is for fully saturated. The same thing I have done for PA case, because that will, what will happen, that will just decrease the amount of PA, it will increase the your seismic component. So that's why your this H bar value will shift towards the up, so we will get a more overturning force, or more overturning moment. So to be in the safe side also, and by using the same recommendation, I just put PA is equal to, I also use the same recommendation to calculate the PA. Just replace gamma by gamma bar minus gamma W into 1 minus RU. Okay, and rest of the things I kept same into KHY. So if I put this value, it will be half into 19.4 minus 10, 1 minus 0.5, Ka is 0.324 into 6 square. So this is 27.4 kilonewton per meter. So del PAE, that will be equal to PAE minus PA. So that is equal to 71.1 minus 27.4. This will be 43.7 kilonewton per meter. So my H bar will be PA into H by 3 plus del PAE into 0.6 into H divided by PAE. So PA is 27.4 into 6 by 3 plus del PE is 43.7 into 0.6 into 6 divided by the total force, that is 71.1. So that is equal to 2.98 meter. So your this H bar is 2.98 meter. Okay, so now I will calculate other forces. The PDW is 7 by 12 kH into gamma W small h square. So this is 7 by 12 into kH is 0.1, gamma W 10, small h is 5 square. So this is will be 14.6 kilonewton per meter. Similarly, PSW, pseudostatic force in seaward side. So that will be half simple gamma W h square. So this is half into gamma W is 10, h square is 25. So this will be 125 kilonewton per meter. Similarly, pseudostatic force in the backfill side, it will be half gamma equivalent into H square, where gamma equivalent is gamma W plus RU gamma bar minus gamma W. So, gamma W is 10, RU is 0.5, gamma bar is 19.4 minus 10, this will be 14.7 kilonewton per meter cube. So, now if I put this value, it will be half into 14.7 into 5 square. So, this is 184 kilonewton per meter. So, all the forces has been calculated. Now, PAE horizontal component. So, that is PAE cos delta plus beta. So, this is PAE is 71.1 into cos delta is 20 degree and beta is 9.6 degree. So, this is 56.3 kilonewton per meter. Similarly, PAE vertical direction, that is PAE into sine delta plus beta, that is equal to 71.1 into sine 28 degree plus 9.6 degree. So, this is 43.4 kilonewton per meter. So, all the forces are being calculated, their point of applications is known. Now, I will calculate this sliding. Okay. So, before that, the sliding part, I have to calculate this W1 centroid position. What is this W1 centroid position? Because the vertically it will act half, but horizontally that I have to first calculate. So, to that I am calculating the W. So, what is the W? I am taking these two triangle and in this rectangle. Okay, divided this two triangle in this rectangle, the total W. So, that I will calculate half into 6 into 1. That is the area of that one triangle into 24 is the unit weight. That is one triangle into two triangles. In half 1.5 into 6 into 24. So, that is the W, it is 360 kilonewton per meter. So, my KHW, that is 36 kilonewton per meter, as KH is equal to 0.1 and KV W part is 0 as KV is equal to 0. Now, the small h, what is small h? Small h is this one. So, this is the small h, say. The centroid position from the base. What is the small h? Centroid position from the base, the small h bar. So, that I have to calculate the centroid position from the base. So, that I can calculate the area of the small triangle. Okay. And taking the lever arm is 6 by 3, this triangle, this lever arm is 6 by 3, this is 1/3 of h, this is the lever arm, I am taking from this base 1/3 of h, and that is for two triangle, 2 plus rectangle 1.5 into 6 is the area, then lever arm will be from the base h by 2. Okay. Divided by total area of that retaining wall. Okay. So, that will be half into 6 into 1 into 2 plus that rectangular part 1.5 into 6, two triangles and the rectangles. So, that h is bar is coming 2.6. So, that means this is your h bar is 2.6 meter from the base, 2.6 meter from the base. So now I calculate the summation of all vertical forces. So what are the vertical forces? The weight will act 360 kilonewton per meter, and the vertical component of PAE, that will also act. So that I will add, that is 43.4. So that is 403.4 kilonewton per meter. Now total horizontal component, that horizontal component will be PAE horizontal plus the two dynamic forces PDW, these two dynamic forces, this one, horizontal component of PAE, and PSW, PS dash W plus PS dash W, but PSW will act in the other direction. So you have to subtract that. You can see PSW direction is other direction, PSW. So you have to subtract that. Then plus your KH into W, because KVW, this force is 0 here, because your KV is 0. So this is KHW also I have to add. That means 1, 2, 3, 4, 5. Okay, so now I will put this value. This is 56.3 plus 2 into 14.6 plus 184 minus 125 plus 36. 36 is KHW is 36. PSW is 184 minus 125. Okay. So this total horizontal force is 180.5 kilonewton per meter. So my factor of safety for sliding for this retaining wall, that is your summation of V into tan delta into base delta, okay, not the field, into the summation of total horizontal forces. So summation of is 403.4 into tan delta is 33.3, that base delta. That base delta is how much? 33.3 delta base, or tan or phi by B. So H is 180.5. So that is equal to 1.5. Okay. Now in the seismic, let's come to the factor of safety part. Okay. So that the for factor of safety for sliding, that is equal to or greater than equal to 1.5 for static. So for the seismic, this value will be 0.7 times of static. As I mentioned, the seismic factor of safety is less compared to the static, because in the seismic there is no, this is uncertain, there is no guarantee this force, this seismic force will come into the structure. But in case of static, it is confirmed that it will come. So and that is generally the seismic factor of safety is taken as greater than equal to 0.7 times of static factor of safety. Greater than equal to. So but here I will take the equal to 0.75 times of static factor of safety. So if I take that, so it is 0.7 times of 1.5. So that should be equal to around 1.125. So this is for seismic. Similarly, the factor of safety for overturning, that will be greater than equal to 2 for static, and again greater than equal to 1.5 for seismic. Okay. Now here E, eccentricity of the loading, should not be greater than B by 6. B is the width of the or base of the wall. This is B. That also you have to check. So, we have to check 3 checking 1, 2, 3. This is because of to generate no tension zone. And the fourth checking that the Q that will act, that should not be greater than Q allowable. So, these 5 checkings I have to do. So, I have done 1 sliding, that is 1.5, which is greater than 1.125. So, it is okay or safe. Okay. Now, we will go for the overturning part, and to overturning part, first I have to calculate the resisting moment. So, which are the forces will give me the resisting moment. So, that means this W will give, this vertical component of PA will give, and this is acting in the opposite, PSW will also give the resisting moment. So, now calculate that. So, resisting moment, so this is total weight is 360 and the lever arm is because it is symmetric, lever arm will be half of that of B. So, 3.5 by B plus the vertical component of PAE, that is vertical component of PAE is 43.4. But what would be the lever arm? Okay. So, it is acting here. So, lever arm will be, if I take the moment from the toe, actually I am taking the moment from the toe. So, what would be the lever arm? Lever arm will be this one. So, first calculate this one. So, B minus this will be the lever arm, that vertical component. So, the lever arm will be of that vertical component this is the lever arm. How I will calculate this distance? Which is very simple. My xi is 80.54, I or xi is 80.54. This height is known, that is h bar. This height, the point of application, that is known, h bar 2.98. So, I can calculate this one. So, this value is coming out to be 0.5 meter. You can calculate that. Okay. So, that is coming out to be 0.5 meter. So, I do not know whether I have, yeah, that is coming out to be 0.5. So, it is very simple how I can calculate that. So, I can calculate, this is your tan 80.54, that will be equal to your 2.98 divided by, so this is x dash. So, x dash will be 2.98 divided by tan 80.54, which is 0.5 meter, Okay. So, now that lever arm will be, it is this distance is from here to here. So, lever arm will be 3.5 meter minus 0.5 meter. So, the lever arm will be 3.5 meter minus 0.5 meter, okay, into plus 125 into 1.7, because here all the lever arms are being mentioned. For PSW it is opposite direction. This will also give me the resisting moment. Okay. So, that the total resisting moment is equal to 972.7 kilonewton per meter and the overturning moment, the horizontal component of PAE, so that is 56.3 and that lever arm is 2.98. the lever arm is 2.98 H bar, okay, plus the 14.6 hydrodynamic force into 2, that lever arm is 2, and 2 times it is been applied because it is free pore pressure, pore water condition, plus 184 hydrostatic in the backfill, 184 into 1.7 again, plus that 36 into 2.6, because I have already determined this is 2.6, H bar dash 2.6, that is the lever arm because I am taking the force, this is 2.6 into 36, that is kh into W, that kh into W it is 2.6, above 2.6 I am taking from here, PSW, all these things I have mentioned. So, from here this force is coming out to be 632.6 kilonewton meter per meter. So, my overturning factor of safety due to overturning is summation of resisting forces divided by summation of resisting moment by overturning moment. So, this is 972.7 divided by 623.6. So, it is 1.54. So, which is greater than 1.5, which is okay. Okay. 332.6. So, now I will calculate the eccentricity, you know that the x, that is summation of resisting forces moment divided by summation of overturning moment into all vertical forces. This is 972.7 minus 632.6 divided by all the vertical forces is how much? Summation 403.4. 403.4. So, this is 0.843 meter. So, your E is B by 2 minus x bar. B is 3.5 divided by 2 minus 0.843. So, which is equal to 0.907 meter. Okay. So, that means it is greater than B by 6 or greater than 0.6 meter. So, it is not okay. It is not okay. It should be less than 0.6 meter. Clear? So, that means it is not, I have to do something, I have to modify the design, or so that I will get that a proper dimension. So, now if this is the dimension, it is safe against your sliding, it is safe against overturning, but this no tension zone, it is not safe. That means that there will be a tension zone will be developed in the base of the foundation, which is not recommended. So, in the next class what I will do, I will take a new dimension and then I will do these checks again, and I will show you that how to save or save this structure, how to save this structure under no tension zone also, and because it is safe already the sliding and bearing. So, no tension zone also it has to be safe, and then we will check the bearing capacity term, that we will do in the next class. Thank you.